Uh, so, uh, just um, so what is the main points of Docker data storage? First of all, maybe it is better to look at this picture on Docker architecture. What about we speak? So we have Docker host who organize the containers in on demand of client's demand. I mean that client uh, want to build new container. He send request to Docker daemon. Docker daemon use Docker files and Docker images. Um, this issues is used um, for management of
$10 меньше
container.
это говорилось,
Sorry?
там что-нибудь там друг.
Okay. So you this no from other side this images is created from um, Docker repository, Docker register. Sorry, no, it's repository of different kind of containers. So we have in this repository we have some typical elements which can be placed into containers. So it's some templates for containers. What is the main problem of Docker? Main problem is that just Docker daemon you know how works these links and so on. So even, for example, if we have containers and on this Docker host we lose Docker daemon, so it's some mistake or some problems with it, all containers under this daemon is broken. Therefore, it's not so state stateless was how to say. Yes, it calls a stateless principle. So application need to be designed so that they don't rely on the data storage in containers. So it means that we organize these containers for by using Docker daemon. Docker daemon knows how it works. These Docker containers, they don't have some, they can't be used for storage some data. They can process something and give back the result for this. So we have possibility to organize the Docker elements, and if you have data inside of the container, it can be loose because can be lost when something will happen with our Docker daemon or with our container. Anyway, I think I said something about this. You can read it. You can read more on different by the links on the presentation. I will send presentation today. And also you can try Docker in your practice works. So you can also, so I think I told a little bit about each of Docker architecture. Do you have question about Docker architecture? Is it clear how it works? Okay, if it's clear, we can compare Docker with some other systems. Other system, it's Podman. Actually, Podman have this quite same architecture as Docker with uh, one difference. In this Podman architecture, we don't have Docker daemon. So this is elements like Docker client, Docker daemon who communicate with each other. In this one, it's not so no fixed. It's just Podman server. Also, we can talk about such differences. Docker runs on a client server architecture. Podman while daemon less. So client server it means that we have client, we have servers as Docker daemon. Podman the daemon less architecture works with daemon-less architecture. Single point of failure. Once the daemon died, all containers died. I told about this. All Docker separations had to be conducted by the user which the same full authority. It means that we talk about security of who can know what information inside of the of the containers. Also, building containers could lead security voluntaries. So we need some instruments for managed security of the containers. It's also is necessary. You have some different utilities who can build Docker containers or um, so to organize its work. I think you can try it in the uh, uh, in our just a minute in our practice works. It was 7.1. So let's continue, and we will talk about next lecture today. So infrastructure and organization. Okay, we talk about this also. Also, we have other system for containerization. What is it's LXC. We can see on the picture its main architectural elements. So we have Docker. It's how it organized host operation system, and then Docker engine. Then in Docker engine we have Docker containers with application. So Docker engine it means this one actually, and the application containers it's something like some independent thing for Docker image. The when we work with LXC, in this way we don't have Docker engine. We just connect containers exactly with host operation system. In this way, containers has some QS elements, so some elements who control quality of service, and some application which is process the request, process the request. So it's in this case, it seems like LSXC more static or more flexible for Docker engine dropped. What about cases it is convenient to use LXC? First of all, if you have a web server site hosted on the decided server and you need to package it in the form of container that can given the developers and or transferred into another server. So what does it mean? It means that in this case, in LXC, this container is independent on the middleware, how to say. So, because you can take this container and move to another server without any problems. In this case, in case with Docker, we can move it, but we just still be connected or to Docker engine, and it's very big difference because from one side we need why we need to move containers because we want to we want to no scaling have instrument to have an instruments for scaling system, but from other side, if we can't scale we can't manage containers to move containers somewhere very far from the this system or this server. It's very big, so it's very important thing for or big difference, and therefore it is necessary to look at LXC. Also, you like to work in an environment where all services are collected in one container. Also, all services in one container, not services is not divided between application and Docker engine, because no, so it's high level of independency. We need isolation on the server so that each web server is in its own container, but it's at the same time not to lose performance as its case with virtual machine. Actually, when we talk about virtual machine, we will see that operational system virtual machine is used is necessary is required more resources for processing, and in this case LXC is some light kind of independent element who can process. So it's very similar, LXC, similar to regular virtual machine. So we need isolation, we need more possibilities, but we don't want to run virtual machine because of its resources usage. So you can use XC, so this technology of virtual machine. Do you have question according to virtual containerization?
No.
As I told, you will receive some practice works where you can try to organize Docker and so you Docker containers, and so you will have possibility to try how it works. Next chapter is virtualization. We also can use virtualization um, for organizing infrastructure for microservice architecture. Because sometimes why we need, for example, a virtual machine when we have so independent LXC containers. For sure, virtual machine gives us more possibility. We can work with virtual machines with independent machine. So it can be useful on some kind of requests. Of even not requests it can be useful it depends on the task which you solve. Approaches to virtualization. There are different kind of virtual machine. And this kinds has difference how to organize the hardware usage. So from one side, we have host machine. It's a machine which is this host, yes, on where the other virtual machine will be based. So hypervisor, it's always installed in base machine. Also, base machine have to have managing guest machine. So we have to have such instruments for managing, for hypervision, for coordination of this virtual machine. Depending on technology used the hypervisor, maybe separate software included directly on the hardware and part of this one can be part of operation system. So what is the difference? You can have some hardware. Then on this hardware you can lay operational system, so a common computer. Then on this inside of this operational system we have hypervisor types two. So it's hypervisor who knows how it works. So it's for example, in this case we we can remind VMware server workstation, Microsoft virtual PC, and others. And after you have this hypervisor who knows which resources to use more, which less, and so on. Then on this hypervisor we have different virtual machine. So virtual machine is placed on hypervisor, and the hypervisor placed on hardware or operation system and hardware, installed on hardware. So we have such picture. From other side, we have another picture when the system doesn't have its own operational system. It can because you haven't you see just a hypervisor on the hardware, and then on this hypervisor you have a different virtual machine also for processing. So it works. Um, so it works. Then um, dynamic broadcast for so we have two, as I talk, these two main points of kind of architecture. They have some differences. So in case when the virtual machine doesn't know that they are virtual, it can be, for example, with VMware or with this example when hypervisor installed inside of operational system. So hypervisor intercepts all commands from virtual machine and process them, replacing them with save ones. What does it mean? It means that what this hypervisor do? This hypervisor do uh, in this case system application inside of virtual machine, they don't know how it should be. That it's independent. It's independent element. So it's very secure because all processes is inside of machine and they're independent. And even what does it mean? I mean that, for example, we have uh, mm, sorry. So we have some commands or how it works processor and so on. So everything, every step of virtual machine reprocessed by hypervisor, and for base operational system for this operational system, all element for this operational system, hypervisor is like application, it's like application which process something. But why I say you about this? Because we lose performance. We lose performance because when each, for example, 1+1 in virtual machine should be re-understand, reprocessed by hypervisor, by operational system, host operational system, then by by hardware. So we have too many layers to process it, too many layers for too many actors inside of this task. But plus good things that is that the ability to virtualize any operational system, since the guest operational system doesn't need to be modified, because today we look through the system for virtualization who rise performance because of application knows that it is not independent, so it's created by special creation. Dynamic translation of MS VMware products. Okay. From other side, this dynamic broadcast. It's doesn't know that the virtual hypervisor accept all commands commands from virtual. I told about this. It's dynamic broadcast. From other side, we have such instrument as parallelization. Why? Because when we speak about independent virtual machines, this independent virtual machine can be processed for no, all requests which they receive. So we can parallelize. So some requests can processed by first machine, some requests can parallelize by a second machine, and so on. So operational system. So what is the better one? It's better one. It's increasing performance, improved performance. We have more possibilities to process. From other side, operational system to the source of which there is not access, we can be used for this technology. Maybe I didn't say about this. It's kind of virtual machine. So dynamic broadcast, parallelization, hardware virtualization. It's types of virtual machine. Therefore, when we talk about parallelized virtual machine, it means that these principles is used for just for machine who should knows about some virtualization process inside of this inside of virtual machine. Also, virtual machine is take some features from this knowledge. So it means that virtual machine modify the processes inside of host for processing, for more faster process. And in this case, when we need to modify operational system in demand of some tasks, it's not good. It's minus for this kind of virtual machines. These ideas used in XEN or KVM. We will look through these elements. And also we have hardware virtualization. To implement the principle of hardware virtualization, manufacturers have to improve the architecture of processor. As I said, the main difference between just virtual machine, between this one and this one, is that we can't work with we can't work as usual with system who don't have its operational system. We have to modify all processes inside of this application to provide the high performance and high quality of the service based service in virtual machine, which is based on which is based on hardware. So to implement what kinds of virtual machines is used use this kind of virtualization. To implement principle of hardware virtualization, manufacturers had to improve their architecture processors. For example, not each processors are ready to change its parameters. But we have lots of solutions with actually with good virtual technologies. So Intel VTX virtual technology, AMD secure virtual machine, and others. So hardware and virtualization is not a way in favor of surprised that solution on the some way. Anyway, what we talk? We talk about the system or technology which is exactly change work of host machine and change itself to process the elements. Okay, here we can see the base component of virtual machine KVM. As I told you, KVM it's partly according to parallelized virtual machine, so quite independent. From other side, it exactly works with principle hardware virtualization. So we have good instrument, cheapless, priceless, sorry, for processing. So um, so we have different sub elements. What really elements is interesting for us? It's QEMU runs as the user space process on top of the Linux kernel. So it works, how to say? So we have from one side we have hardware. From other side we have Linux kernel. It means that this kernel was modified with KVM module for make for do job with this interconnection of hardware from one side it's hardware, from other side it's application. So we need some modules who knows how our services is needed from one side, and from other side what we can do with that application. Then we have user space processes. It's like containers, but also you have to have container virtual machine. From other side, we have to have some management board for virtual machine. From one side, it's guest user space process, guest kernel for each Linux kernel for each virtual machine, and KVM, which is process runs on user space processes on the top of Linux kernel. So it works in Linux kernel, but it's independent thing and work together with other modules. Also, QEMU can co-work with KVM or hardware based virtualization, like from parallelized virtual machines. Then for usage hardware-based virtualization, QEMU doesn't have emulate all CPU instructions, so it is really fast. What does it mean? It means that in this case, we don't have necessary to uh, which system who has real overload the hardware from one side. From other side, each module does its own job for making the end user server better. It was about KVM architecture. Also, we have how to say, virtual machine, virtualization parallelization. So it's the third one for third class for virtual machines. Here we have the similar one. So we have memory, CPU, and so on. So some physical host. Then this physical host has such kind of hypervisor. It which has scheduler, MMU, times, interrupts, some elements which imitate the progress of computational resources. From other side, we have different virtual machine, which is placed on this Xen hypervisor, and this virtual machine has some application. It's a guest. It has its own guest operational system and so on. It's okay. I have lots of slides with this. Okay, I will talk shortly because I think we lose lots of time. So from one side, from other side, we have some virtual machine or daemon who uh, who knows how to communicate with hardware elements. So, and this native driver is a kernel for all system which is on this branch on the server. So different virtual machines. One different virtual machine with application and guest operational system, and one virtual machine with system service, which is not gives the possibility to do something wrong. It's kind of machine. So maybe you will see if you wish. Here we can look through different kinds of virtual machines. So from one side, virtualization in Xen virtualization is using the split driver model. The model of primary or used for plan network and storage virtualization with LVM. So with different elements. From other side, virtualization is used QEMU, user space backend drivers. A QEMU, so it's backend. What does it? What we these different things? We have a front end driver in a virtual machine in host virtual machine from one side, and we have mu QEMU back end driver who communicate with front end driver and knows how it works and receive all information for transmission. So it's it's virtualization in Xen. From other side, we have some processes inside of these elements. So device emulation QEMU communicate with device driver in each virtual machine from one side, and also we have device driver who communicate with phys hardware. So it's very how to say, these elements do its job for fast processing, for very fast processing. On this slide, we have some storage option with Xen. Maybe it is not so interesting, but sometimes we don't remove storage. Also, for example, for LVM system, where the storage, gas storage is disk make images in files on local file system. From other side, it's remote storage is used for virtual machine, so you can manage it with different kind of virtualization. So here some examples. Here some examples, and with some links you can look through. Also, so look, when we talk about virtualization and modification of operational system for installing such kind of such kind of containers or containers, virtual machines. So we can вот, значит, so from one side we need to organize processor time, processors. From other side, we need to organize memory. From other side, here we have to organize networking, how to connect that virtual machine to network to network also. So we have to have to install bridging software packaging, have to set up the network bridge on them on this supervisor machine. From other side, to connect this virtual network devices to the network with entry write such elements on the machine. So without this network, sorry. Without this networking, we can't organize network inside of virtual machines. So it's also thing what we should remind. So console setup, running connection, and so on. You can also all this you can try using this presentation. Using this presentation. It's time to finish for us, and we have повітряна тривога. So I sent now these files for our chat, this presentation, and you can look through these links which inside of the presentation, and maybe there is some instruments for so some help for this virtual machine Xen server. So I think it can be useful for you. Okay, about Kubernetes we will talk next time. Thank you very much. Do you have question for me?
No questions.
Okay, thank you. Take care of you. See you next Thursday. Goodbye.
Yes.
Goodbye.
Goodbye.